Rounding. When you are asked a number, you'll be told how accurate your answer should be. This is called the degree of accuracy. Whatever the degree of accuracy, the method is always the same. So look at the digits in the position of the required degree of. What you do to this digit depends on the value of the digit to the right of it. So if the value of the digit to its right is 5 or more, so we are going to increase the original digit by 1. But if the original value, or if the value of the digit to the right is less than 5, so we are going to leave the original digit as it is. Now, let's look at the following examples to explain what we are talking about. Now, example 1. Round each number to the given degree of accuracy. Letter A, 64 to the nearest 10, 376 to the nearest 100, 23,252 to the nearest 1,000, then 26,500, 26,580,000 to the nearest million. Now, solution. So this one to the nearest 10 now. So we know that 10 has just only one 0, right? So to run this one to the nearest 10, so the first digit here is 6. Then digit to the right is 4. So it's less than 5. Is that clear? So we're going to leave 6 as we have it. Then we turn this 4 to 0. So to the nearest 10, 64 is equal to what? 60. Exactly. Now, the second one to the nearest 100. So as we pronounce this one now, so the answer should be either between 300 or 400. Now, the 100 units here is 3. The number to the right of 3 is 7. So 7 is greater than 5. So we're going to increase these digits by 1. So if you increase 3 by 1, so you are going to 4. Then you turn the remaining digits to 0. Is that clear? So this one will now equal to what? 400. So to the nearest 100. Now, the third one to the nearest 1,000. So as we pronounce this one now, 23,000. So we can see that 3 is in the position of what? 1,000 here. Now, the digit to the right of 3 is 2. And 2 is less than 5. So we're going to leave this 3 as we have it. Is that clear? So this one to the nearest 1,000 will now be 23,000. So that we turn the remaining digits here to what? To 0. Is that clear? Now, the last one to the nearest million. So when you pronounce this one now, you will say what? 26 million. 26 what? Million. So 6 is in the position of what? Million here. Now, the digit to the right of 6 is, so you are going to increase this 6 by 1 because the digit is what? Is 5 or more. Is 5. Yeah. So if that one is clear, so you are going to increase 6 by 1. So this 6 will now turn to what? 7. So we are going to have 27 million by changing the remaining digits here to what? To zeros. Is that clear? So if this one is clear, so this is how to convert a number to what? To the nearest 10, 100, 1,000, and what? Million. Now let's look at example 2. Round each number to the given degree of accuracy. So 12.67 to the nearest whole number. So this one to the nearest whole number as well. This one to the nearest to 1 decimal place, and this one to 2 decimal places. Now let's see the solution of this one. First one, so we have 12.67. This 12.67 now, the whole part here is 12, and decimal part is what? 67. So the whole part. So we're going to round up this one to the nearest whole number now. So the last digit here is what? 2. So the number to the right of 2 is 6, and 6 is greater than what? 5. Increase these two by what? by 1, and we turn the remaining numbers here to what? To zeros. So here now, if you increase 2 by 1, you are going to get 3. So this one is equal to 13. Or if you write 13.00, is the same thing as what? 13. And since you are asked to change to what? Whole number. So the whole number part here will be what? 13. Is that clear? Now the second one is 0.721. Now to the nearest whole number, the whole part here is 0 and the decimal part is what? 721. Now the digit to the right of the whole number here is what? 7. So since this 7 is greater than 5, so you are going to increase the original whole number here to by 1. So if you increase a 0 by 1, you are going to get 1, and that is the answer to the nearest what? Whole number. Now letter C, 2.706 to 1 decimal place. Now 2.7, so the first digit after decimal place is what? 1 decimal place. Now the digit the digit to the right of 7 is what? Is 0. So 0 is less than 5. So you are going to leave 7 as we have it here. So you are going to have what? 2.7 as the what? 1 decimal place. Now the second one to 2 decimal places. So what this means is that we want to see 2 digits after decimal points. Exactly, that's the meaning. So to see 2 digits after decimal place, so the 2 digits here, they are what? 4 and 6. 4 and 6. They are the original number now that we want to we are finding now. Now the digit to the right of 6 is what? 9. That means we are going to increase 6 by what? By 1. So if you increase this by 1, so this will become what? 7. So this one will now turn to what? 0.47. So to 2 decimal places is what? 47. As you can see it now, after decimal points, we have 2 digits. So after decimal points here, we have what? 1 digit, because it's 1 decimal place. Is that clear? Now the last example now that we are going to look at is on a significant figure. Now let's look at the significant figure. We are asked to change 193 to 1 significant figure. Now to change this one to 1 significant figure, so the first digit here is 1. That is the 1 significant figure. Now the digit to the right of 1 is what? Is 9. So that means we are going to increase this 1 by 2, because 9 is greater than 5. So if you increase 1 by 1, so it will become what? 2. So then you are going to turn the remaining digit to 0. So you will now get 200. So to 1 significant figure is what? 200. Is that clear? Now second one now is 0.64. Now one thing I would like you to get clear about a significant figure is that if you have a 0 at the beginning, so that one should be what? Countless, because a 0 is not a real number. Is that clear? So you are going to start your significant figure from the first non-zero digit. So the first non-zero digit is 6. Is that clear? Now since 6 is the first non-zero digit here, then to the right of 6 is 4. 4 is less than 5, right? So that means you are going to leave 6 as you have it here. So this one to 1 significant figure is what? Is 0.6, because 6 is the only significant figure here. Is that clear? Now third one is 0.0306. 2 significant figures. Now the first non-zero digit here is what? Is 3. Now this is 0 that we have in between 2 numbers here. Now you are going to make use of this 0. Is that clear? So because you have a 0 here, a 0 here, so they are not a real number. So we are going to say that first non-zero digit is what? 3. We are going to start our counting, our significant figure from first non-zero digit, and the first non-zero digit here is what? So let's start from 3. Now, to the right of 3 is what? Okay, to two significant figures. Okay, so we are going to count 3 and a 0. 3 and what? And a 0. So a 0 is the last significant figure here. Now, to the right of a 0 is what? Is 6. To the right of 0 is what? Is 6. So you are going to increase a 0 by 1 because 6 is greater than 5. Now, since this is greater than 5, so if you increase a 0 by 1, so you are going to get 1. That means we are going to turn this 0 to what? To 1. So this one to two significant figures is the same thing as 0.031. So this is 0 after this one. If you like, write it. If you don't like, so it doesn't make any change. Is that clear? So there's no any change. If you like, write this 0. If you don't like to, so if you stop at 0.031, you are still correct. Is that clear? Then letter D, to two significant figures. So the first non-zero digit here is 2, then and 3. So 2 and 3, they are the number we are concerned about here now. The two significant figures, the what? 2 and 3. Now, to the right of 3 is 4. So 4 is less than 5. So we are going to leave this 3 as we have it. So you have 2, 3. Then the remaining digits, turn them to what? To 0. Then the last example here is 241. Then to three significant what? Figures. Now, the first three non-zero digits here, they are what? 2, 4, and 1. 2, 4, and 1. Now, to the right of 1 is 2. And 2 is less than what? Than 5. Since 2 is less than 5, so you are going to leave 1 as we have it. So we have 2, 4, 1. Then you turn the remaining digits to what? To 0. So that's why we're having 2, 4, 1, 0, 0, 0. Is that clear? Because we have 3 digits after 2, 4, 1. So turn the 3 digits to zeros. Is that clear? So you have 2, 4, 1, 0, 0, 0. So if this one is clear now, so I would like you to do this exercises for me. So round each number to the given degree of accuracy.